Okay, you guys learned how to make a system of equations into an augmented matrix. And it looks something like this. You just take the coefficients from each of these variables and you throw them down here. The equal sign is kind of like the dotted line right here. The constants in each of the equations are on this side in the matrix. You'll notice something different about this system of equations in that it says x sub 1, x sub 2, and x sub 3. The same idea if it was x, y, and z. Don't let those numbers trip you up. Those sub numbers like the 3 and the 2, those are just saying that those x's, those variables, are different from each other, kind of like x and y are different. Well, this is kind of like vocabulary because I'm just telling you that you can write this matrix a different way. You can write 1, 0, 2, all these numbers are the same, except you don't include the constants in this one. Instead, you multiply the matrix by x sub 1, x sub 2, and x sub 3, and this is supposed to equal negative 4, 4, and 2. So these numbers, what it equals, is what our constants are, and these variables are actually the variables that are attached to all of these numbers right here. And it's kind of neat because if you actually do a matrix multiplication right here, you can watch another video for that, you can see that when you actually multiply these two matrices together, these variables get attached to these numbers just like up here. And so we get something that looks very similar. That's actually kind of neat when you think about it. Here, just let me give you one. I'll just multiply one row. So remember, when you guys multiply matrices, do matrix multiplication, you go across for the first one, you go down for the second one. And since this is a 3 by 3 and this is a 3 by 1, you can see that we can multiply these together because the columns here match up with the rows here. And so it'd be 1 times x, which would be 1x, negative 2 times x squared, I'm sorry, not x squared, x sub 2 would be negative 2 x sub 2, and then 1 times x sub 3 would be plus 1 x sub 3, and that would equal negative 4. So you see how we got the same first equation, and I can keep doing that, you know, and get right back to this system of equations. Now, the reason why I'm showing you this is because this can be written a different way, a little more simply, like so. Get rid of all that purple writing. This would be matrix A. This would be matrix X, capital X, and this would be matrix B. Matrix A times matrix X equals matrix B. And this equation right here, I mean, is a matrice equation. All these variables represent matrices. Can help us solve a big old system of equations like this. This is a really nice, pleasant way to represent how to solve this. And the reason why I'm showing this is because of our next slide. Now I'm going to show you something that you guys are all very, very, very familiar with. This guy right here. He's just a linear equation. And when we go to solve this, the way we would go about doing that is we would divide by 6. Most of you guys would say, oh, divide by 6. And that works, and that's true. But instead of dividing by 6, let's multiply by the inverse of 6, and or some of you guys would say the reciprocal. Well, the inverse and the reciprocal are the same in this case because in multiplication, the multiplicative inverse, which is this word right here, is the reciprocal, and that's what we're looking at. We're looking at the multiplicative inverse, and the reason why it's 1/6 is the multiplicative inverse of 6 is because when you multiply 1/6 to 6, you get 1. So we would go, we multiply it straight across, and we cross out the 6's because we can cross cancel. You get 1. 1 over 6 times 6 equals 1. And then you would have x, and over here the 6 would cancel out with the 78, and that would be a 13. That would be a 1. So anyways, x equals 13. That's great and everything, but that's not the important part. And the important part is, what is this thing called? And this is called the multiplicative inverse. This number right here is called the multiplicative identity. Multiplicative identity. And that's what we want. We want the 1 in front of x when we're solving it. Because if it just says 1 times x, then we know that the number on the other side of the equal sign is the answer. So let's look back here at our matrix equation. How can we get rid of this a? Some of you guys might say, oh, just do the multiply by 1 over a. That's a great idea, and that's actually pretty good thinking. That is the inverse. This is the multiplicative inverse of a. But how do you write that? Like, how does that actually look as a matrix? If we were looking at a matrix, how does the multiplicative inverse matrix look, and how do we find that? Now we normally don't write it like this. Instead, we write this like a to the negative 1, and then we would multiply it times ax, and we would multiply the b on the other side times the inverse of a. The inverse of a and a would multiply together to cancel each other out, and you'd be left with x equals b times the inverse of a, which is kind of interesting, because if we stop for a moment and go back to our previous slide, here it is. We have, oops, it's got all this purple stuff. Hold on. We can find that. We can solve for this x just by multiplying both sides by the inverse of a. That would cancel those out, and then I would have x alone. So then you would get this alone, and you would find out what these values are. But the question is, what does that look like? If this was my inverse function right here, a to the negative 1, what does it look like, and how do we find that? And that's what I'm going to show you right now. Now remember, on the previous slide I showed you that the inverse of 6, the multiplicative inverse of 6 is 1 over 6, because when you multiply them it equals 1, the multiplicative identity. Well, if I had a matrix and multiply it by the inverse of itself, I should also get the multiplicative identity. But the multiplicative identity for a matrix is represented as I. I, as a matrix, the multiplicative identity matrix for a 2 by 2 looks like this, which you guys should recognize as reduced row echelon form. That is the identity matrix. So whatever the inverse is of this, if I multiply it, let's see, we have 1, negative 1, 4, negative 3. If I multiply this matrix by the inverse, I should get 1, 0, 0, 1, the identity matrix. So what is that? How do we find it? Well, let's go ahead, let's throw in some variables here. Now this would have to be a 2 by 2 matrix here. And to figure this out, let's go ahead and let's multiply these two matrices out and see if we can solve for these variables. Okay, so we would multiply this row with this column, and so to do that we would get 1x to the sub 1 plus 4x sub 3, right? We go down to 3, multiply the 4 times it, and that would equal 1. This guy right here. And actually, I probably shouldn't write it that way. I should instead just keep that like that and keep this side like this, so you guys can see why it equals the 1. And then to find our next number, okay, we found that number. To find our next number, we would go this row, -1 times x sub 1. That would be negative x sub 1. And then -3 times x sub 3, so it would be minus -3x sub 3. And then right here, we would go back up to the first row. We would go 1 times x sub 2, so we have 1x sub 2 plus 4 times x sub 4, so we have 4x sub 4. And then the second row, -1 times x sub 2 would be negative x sub 2 plus -3 times x sub 4. -3 times x sub 4. And this, since it corresponds with the 1, would be written as x sub 1 plus 4 x sub 3 equals 1. And then the other equation here, expression with the x sub 1, x sub 3, would be negative x sub 1 minus 3x sub 3 equals 0, because that number corresponds with it. So that's one system. And then the other system would be x sub 2 plus x sub 4 equals 0, because 0 corresponds with it. And then for this expression, it would be negative x sub 2 plus negative 3x sub 4 equals 1. And there's your other system. Alright, let's clean this up. Now, we would have to solve for both of these systems in order to find out what our identity matrix, or not identity, what our inverse matrix is for A. So for this top one, you would set it up like this. You would go 1, 4, -1, -3. Then you have a 1, 0 right here. For the other one, you would say 1, 4, 0, -1, -3, 1. And those are two matrices that you would have to solve for in order to find our inverse matrix. Now, there's a little trick you can do from here. We could, if you notice, you see how these are the same? We could write this as, the book calls it a doubly augmented matrix. We could write it all together with as 1. We can write 1, -1, 4, -3. Now on the other side we write 1, 0 from this one, and then we write 0, 1 from this one. And this is our doubly augmented matrix right here. It's not our answer, but that's what's going to help us find what the inverse matrix it actually is. And I'm going to do that for another video because this is just getting way too long right here. So I'm gonna copy that doubly augmented matrix over in the next video, and then we're gonna solve it, and you'll see how you actually find the inverse matrix.